What's up, math crew? We're just going to take a look at how to pull function values off of a graph that already exists. And the key is to understand the link between ordered pairs, just x comma y, and how we would restate that same information using functions. And that's going to appear as f of x equals y. When you substitute an x value into an equation, you get the corresponding y value that belongs on the graph. So let's take a look at number 13 together, and maybe you can try number 14 by yourselves and check with my answers. Okay, something like number 13, I'm asking you to fill in f of 2 equals blank. So remember, if we're looking for an ordered pair, we're looking for an ordered pair where the x value is 2. So let's go find where that happens. Here's where the x value is 2. Looks like the y value is -2. So that's what goes on the line. Similar for the next problem here, f of -6. I'm asking you, okay, look at the graph and find me where the x value is -6. Tell me what the y value is. So as we look at that, here's where the x value is -6 and the y value is 0. Okay, next one, f of what equals -3. So we are now looking to find anywhere where the y value is -3 and report the x value. Well, let's take a look. Here's where the y value is -3, anything along this horizontal place here. And there is one location where that graph exists, and turns out x value is also -3. Okay, last one to look at, where can we find f of 6? Well, f of 6, turns out it has an open circle at its location, meaning there is no function value corresponding to an x value of 6. There is no ordered pair 6 comma something, because that's not really there. So f of 6 is undefined. Okay, let's move to domain. Remember, we state that how far to the left and how far to the right our graph extends in terms of x. And the graph extends out to -6. That is the lowest x value we see. That point's really there. I'll use a bracket. We do have a continuous graph. We can trace all of the points, and it extends as far as this place right here. Notice, though, there is an open circle, so I will use parentheses around that x value of +6. Okay, range, low to high. Say it with y. Let's see, the lowest x value down here is -3. The highest y value appears either here or here, and either place you look, that's a y value of +3. So there's our range, low to high. Say it with y. Okay, let's take a little journey along the graph, always starting from the left side. So here's our little stick figure, going to walk along the function. And as soon as we start our journey, we are walking uphill. So there's an increasing section. Now we turn around and we head downhill. There's our decreasing section. And remember, we will use x values to describe this journey. All right, now we are increasing again until we reach right up to here. So there's my increasing section. We have a new decreasing section, decreasing, 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 and we reach this little juncture, but we still keep going downhill, so this entire section is decreasing, and then we end our journey walking uphill. Okie dokie. All right, let's look at our little number line right down here and convert this information into some good interval notation. So the first increasing section goes from -6 to -5. Our next goes from -3 to -1. And the final increasing part of our journey goes, put that on the next line, from 2 to 6. Okay, our decreasing portions of the journey from here to here, -5 to -3. And the other portion of our decreasing journey lives between an x value of -1 to a y value of 2. Could you please pause, try your best at number 14, and check your answers with what you see here. So just as some quick explanations, now that you've completed this all on your own, I'm sure, we should not have had a big problem with g of -1.15. We can get that right off the graph. Ordered pair is right there for us. Perhaps g of 3 may be a little tough. The graph does not give us that information, but good thing we had the formula here, the equation. So substitute the 3 where the x was. Compute. 3 cubed is 27. 4 times 3 is 12. Subtract those two. There's your g of 3. Okay, domain all the way left, all the way right. Range all the way down, all the way up. I didn't write the number line down below, but these would be the increasing and decreasing sections. And the end behavior states the left end points down. That's our first line. And the right end points up. That's our second line. Now we can look at the x-intercepts on the graph. We have -2, 0, 0, 0, and 2, 0. We can also verify those algebraically by substituting 0 for the y and solving. We can verify from the graph as well the y-intercept is 0. And we could also get that algebraically by substituting a 0 where the x is. And that will be some of the algebra you will need to use to compute x and y intercepts from equations of functions. That's all for now. Ta-ta.